Okay, so for today, lesson 1's assignment is on page 101. We asked you to do practice number 1 to start off with. So let's go ahead and look at practice 1. Consider the 3 sequences, so we're only doing the first one. For each sequence, describe the pattern, then represent the sequence as a numeric sequence and as a table of values. Okay, so as we've been doing here in our notes, this is figure 1, figure 2, figure 3, and eventually we're going to create figures 4, 5, and 6 once we see what's kind of going on here. So let's count up how many we got. In the first figure, we have 4 total matchsticks. And then in the next one, we have our original 4 right here. All right. And then how many more do we have after that? We added in 1, 2, 3, 4, 5, 6, 7. So we had the original 4 plus 7 more. We now have 11. And then here, in the next figure, figure 3, is getting a little bit more involved. We know from our previous answer that all of these add up to make 11. So then we just added on 1, 2, 3, 4, 5, 6, 7, 8, 9. We added on 9 more. So 11 plus 9 is what? We've got 20 there. So as we're doing, we're increasing by 7. We increase then by 9. And then if we were to draw another figure, trying to draw that figure would be, well, a pain in the butt. So we want to kind of take what we've been looking at here and try to create a pattern off of this into our table. So they didn't leave us a lot of room. I'm going to go up here to create our table that we've been doing. The first column, what we call ours our domain, is the term number. And then the second column, the range, will be our term value. So the term number is however many figures we had, figure 1, figure 2, figure 3, whatever we found in there. And they want us to do for 6 of those. And, well, I'm going to run into my picture here. So let me try to sketch this out just a little bit better real quick. Slightly better. So for the first figure, we found we had 4 sticks. And on the second figure, we found we had 11 sticks. And for the third figure, we found out we had 20. Okay? And we said we increased by 7, we increased by 9. So what do you think we're going to do to go from figure 3 to 4? Because I am sure not drawing that out. Increased by 7, I increased by 9. So that looks like it's going by odds. So if I would increase by, say, 11, we'd be at figure 4, which would be 31. Increase by 13. 31 plus 13 is what? 44. And increase by 15. The next, add 2 to that. 44 plus 15 is 44, yeah, plus 15 is 59. And there's my 6 then figures. What would be the case if I attempt to draw that out? So it's trying to figure out what the pattern is and seeing what is going from one to the next. All right, I also asked you to review 1A and B. So here we want to look at the scenario and identify the appropriate family. So that's linear, exponential, quadratic, piecewise, and I'm not sure which one I forgot to name. Describe the domain and identify the graphical behavior as increasing, decreasing, or some type of combination. So on letter A, the first thing I notice is we got a city in this scenario. Discovers that population has been tripling, getting pretty quickly every year. So each year, this graph is going to increase very, very quickly. And I said the word increase, so I just answered part of it. This is an increasing, and it's that curve, which we call exponential. So it's an increasing exponential curve. And again, what we want you to associate with exponentials is it looks like something to the x power, okay? So it looks like something like that for the function, okay? Something to the x power. So it's increasing exponential. And then the domain, okay? The domain here is going to be then the real numbers. It's going to be the time in real numbers. In this case, the real numbers, meaning, well, we're starting at 0 for time. So it's not all real numbers, it's the real numbers starting with 0. Okay. Another way you could write the domain is like this as well, as our inequality starting at 0 and then going to infinity. Letter B is doing the same thing. All right, so let's look at letter B here. A vacationer has $300 to spend over the next 20 days. It's quite a vacation there. The first 2 days, she spends $20 on food. So she starts up here at $300. She spends $20 on food. She visits with family members the next 4 days and does not spend any money. So that's nice. No more money spent. She then spends $20 in transportation on each of the remaining days until she spends all of her money. So 20 days, $20 each day until all of her money is gone. So what we want to talk about is this graph. It was decreasing, it was constant, and then it was decreasing. And when you have multiple things happening like that, with a constant in there, this is what we call a piecewise. More specifically, a linear piecewise function. Now that linear piecewise function was decreasing and constant. Okay? And then the domain, okay, is going to be our time, okay, in days. And it's going to be also the, because we're talking days, we're not saying all real numbers. What we're going to be doing here is saying all the whole numbers, okay? Because whole numbers are 0, 1, 2, 3, 4. And because we're, sorry, I saw something. All whole numbers. So with that in mind, days are not including a fraction of a day. So every day you just spend $1 or spend $20 in this case. So we're talking about just whole numbers. We don't want decimals and fractions. That's why I'm not using the real numbers in this case, okay? And last one I want you to do is number 2. Determine if it's a function or not. Remember, I look at the domain, and in this case, see if there's anything repeating. -5, -6, -2, -1, and 4. Nothing is repeating, so that is a function. And letter B, 2 to 9, 2 to 4. That cannot happen, so this is not a function. Remember, that 2 cannot be